Okay, our last real lesson of this entire unit, and truthfully for the school year, is all about these integrals. And I think this is more common sense than even something I need to teach per se. But when you look at these shapes and this type of a graph, this applies to any kind of graph, whether it's a parabola or a cubic, whether it's quartic or any kind of crazy polynomial. And even in your trig functions and other kinds of graphs that you'll get into next year, this integral rule is truthfully the essence of integrals, that we can split it up into parts as well as putting it all together as one whole. And so let me illustrate that today as we look through these examples. The first thing I want you to see is, okay, I want the integral or the area from 0 to 1. And so basically, I'm just going to do the area of a triangle. And so 1/2 base times height. And of course, the base is 1 and the height is 1. And so this would be 1/2 times 1. So that's just 1/2. If I asked you the area from 1 to 3, what would that be? How would I find that? Excellent. 2 times 1, which of course is 2. And then 1 to 4. So now this is a different dynamic. See, from 1 to 4 would be that we are going from 1 all the way here to 4. So it not only includes the rectangle, but also the triangle. So how could I do that? Any guesses? Hopefully, again, this makes sense that what you're doing is you're basically combining this rectangle and then this triangle. And this triangle is similar to the one on the other side. It's also 1/2. So that would be 2 plus 1/2, or 2.5, and some of you might prefer 5/2. Either way, works just fine. So 0 to 6, in a similar fashion to what this is, you would literally count up these areas. So you have the 1/2 for here, you have the 2, and you have the other half. Okay, that'd be 3. And then this triangle that's dipped down here, that's 2, and the height of that is 2. So that itself is -2. So what I would have here is 3, well, maybe I'll even write it like this, 1/2 plus 2 plus 1/2 minus 2. And so I get 1 as my final answer. So what exactly am I showing here? I mean, as I told you, this is pretty much common sense. The integral rule that this is basically showing here is what you see in front of you, and that is that we can break up an integral into 2 different parts, and it still equal the whole. That the 2 parts added together equal the entire thing. Notice how it starts, and it goes from A to B, and then the same letter is going to be in the base of the other one, and that's how I know it's just one fluid section. It doesn't have to be one fluid section, but if I want the continuous from A to C, then yes, it does. This can be applied in so many different facets. If there's something you can't find the area of, or some part that you might be able to do graphically, and another part that you have to do that trick with, you can combine those 2 together, but you can separate them initially so that you can handle them in a level that you can deal with. So we'll get into this more actually next year with absolute values and with all kinds of what we call chain rule type questions, and this has all kinds of implications. So good luck and enjoy.